In the last video, we went over the forward click method to creating an anomaly detection algorithm. So what we're going to do now is kind of step more into that clustering type algorithms and see what algorithms we have listed there and some of the advanced settings that you can do to actually customize the model itself or all the parameters from pre-processing, hyperparameter, optimization, and things of that nature. So we're going to go ahead and go back into our projects. I am going to go to our demo anomaly detection. And what I'll do here is do clustering. Create the analysis. And again, selecting which tags that we want to include in this analysis. And here we're going to include all of the tags themselves and go ahead and click next. So for our algorithm type, we are going to be using the clustering algorithms. And the algorithm names are listed below. So in the previous video, we did the auto selection feature. And if we look at the advanced settings for the auto select feature, you can see we have options for downsampling, pre-processing, dimensionality reduction, and which ML models are included in this auto selection. So you can come in here and select or deselect any ones that you don't feel is appropriate for an auto select feature. If you just want to do a quick k-means, GMM, and mean shift, all you would have to do is have these three clicked and selected. But we're going to go ahead and go back and show you more of what this system has to offer when it comes to selecting a single algorithm type and single algorithm. So I would just go here, drop down the menu, and go to the GMM, just for example. In the advanced settings, you can see now it's a little bit different. We're able to determine what kind of scoring mechanism we want to use, the cross-validation, how many n-folds we want to perceive, the pre-processing parameters, so we can come here and select which ones we want to use, with centering, with scaling, dimensionality reduction parameters, and you see the full list of all the different methods we can use for that. The algorithm parameters themselves, if we want to use grid search and which components we want to start and end at, including the steps, the covariance aspect of it, and then also the anomaly parameters, the acceptance rate, the window length, and the actual anomaly percentage we're going to perceive as an actual anomaly from normal data. All of these consist of a single part or a multiple area part of the model train that we create. So to put it in perspective, each SORBA or machine learning agent that we create on this tenant and that we're able to deploy to the SDC has multiple stages, multiple steps that are included within that model. And you can think of it as one model, one algorithm for filtering, taking in that information, ensuring that it's filtered before it's processed. Then also we have the pre-processing of that information coming in. Then also the hyperparameter optimization aspect is another part of that pipeline. And then in the end, it's the post-processing and the actual output of what you're getting from those algorithms. So if you think about it, this could include 4 to 5 different areas that can be customized that create your full working SORBA. So once we have it to an area that we believe we can use, and again, we try to make this platform as easy as possible. These advanced settings that you see are for those who understand the back end for a lot of the machine learning aspects. If they're a data scientist or if they have, which each one of these steps do to help either cleanse the data out, provide help for the algorithm itself to run more efficiently, things of that nature. But we have our own kind of secret sauce that goes through these steps and tries to optimize that algorithm for you. So for those who don't understand or don't want to go through coming into here and customizing each individual algorithm, that's where we have that auto select feature, where it goes through the main clustering algorithms that we believe provide the most value. And then it also has the optimization of this advanced setting here. So we'll go ahead and keep the GMM, go back to the main settings here. I'm gonna just do no pre-processing, I'll select a different type of dimensionality reduction, and everything else seems to be fine. And I'll go ahead and hit next. And again, selecting which version of the data you want to bring in. Here we only have one version of the data, which is fine, and go ahead and hit play. In the screen, it has the same options as you would for the 4-click method. The ability to retrain the model with new data, to view all of the output information and some of the building information on that algorithm itself or that model, to use the offline predictor to compare against or validate this algorithm or compare it to new data sets coming in, downloading a zip version of this algorithm or this model here so that you can manually deploy it to a SDC or box, delete. You have the option to deploy these models from the IoT platform down to the SDC or undeploy them from the SDC themselves. Now that the model is ready, we're going to go ahead and view. So as you can see here on the left hand side, again, we have all the model settings, the performance, pre-processing, dimensionality reduction, parameters, the anomaly detections, all of the stuff that we can set in the advanced settings are there. Then over here on the right hand side, we have the anomaly detection, all of the views for that. So we have the features, which is just the raw data that we brought in, the ability to synchronize the graphs if needed. So I can come here and you can see it does not affect the other graphs, but if I synchronize it itself, I can come into this graph, select the region I want to investigate, and go ahead and start looking to see, okay, what tags may have correlated to this type of issue. And we'll go over the next steps in a sense of an investigation. We typically will take in anomaly data, or let's just say raw data, without any understanding as to the CMMS aspect of it or any of the actual critical events that may have occurred within that data set. And from there, we take that data set, apply, like you see here, an anomaly detection or clustering type algorithm, and we would just process throughout the system or throughout the data set. We would see some of these anomaly detections or these anomalies that have occurred within the data set, and then we would build a clustering algorithm from there. And so in the next video, we're going to go over a little bit more about the clustering algorithm and the work item area. Both of those go hand in hand when creating those clustering algorithms, and we'll go over those steps in the next video. Also, for the clustering algorithms, we have, again, the predictions. So the prediction 0 to 1 from what we were processing itself and all the different clusters, and the probability, cluster 1 and cluster 0. And again, you can turn this on and off and double check to see if this data makes sense. All in all, this is what we have for the clustering type algorithms. And go ahead, feel free to play with all the different types of algorithms or different models that you can use within this algorithm type. And feel free to just go through the advanced setting and just see what happens when you play with each one. We want to make our interface as user-friendly as possible, and to help some of the engineers explore what each individual aspect of the model settings can do for the overall model itself.